All right.
Start on 4?
Yes.
All right. We can always go backwards.
Yes.
Now, as you can see from my page, I am not seeing anything.
Okay. So it's the first question for A. It's open parentheses, 3x squared, and then y to the negative fourth, and then closed parentheses, and then to the power of negative 3.
Like that?
Yes.
Okay. What is this equal to? Hold on. I'm not done. What is that equal to? In other words, when you have exponents like that, double exponentiation, what do? There's a rule.
Do you add them or do you
Multiply them.
so it's
If I had this, then you add them. But this is not multiplication. That is double exponentiation.
okay.
So you multiply.
So it's x to the 6th.
Exactly. And that's the rule we're going to use on this problem.
Okay.
In other words, the very first thing to do is multiply that minus 3 by each term. In other words, this minus 3 has to be applied to the 3, to the x squared, and to the y to the minus 4th.
Okay.
So what's that equal to?
So -9.
No. Let's start. Let's just plug it in.
Okay.
In other words, it was 3 to the 1. We're multiplying 1 times minus 3. So now it's 3 to the minus 3. Times what? Times how many x's?
-6.
And the y?
12.
Okay. Now, what's that equal to?
-9.
No.
+9?
The most common mistake I find that students make in algebra is they assume that negative exponents mean a negative number. They almost never mean a negative number.
Okay.
3 to the minus 3 means 1 over 3 to the 3.
Okay.
That's all you do. When you have a negative exponent, make it the reciprocal to a positive exponent. And that's equal to 1 over 27.
Okay.
Okay. So we can start off. We're going to have a fraction. We know 27 belongs in the denominator. That takes care of that. Where am I going to put my x to the minus 6th?
On the bottom.
And make it x to the positive 6th.
Yeah.
And then where does my y to the 12th go?
It stays on top.
And there's your answer.
Okay.
Just take it term by term. If you had 16 variables, do it variable by variable. Doesn't make it any harder at all. It just, okay, what's B?
B is 2m to the negative fourth, and then over open parentheses 2m to the negative fourth, close parentheses to the power of 3.
Like that?
There's only one parentheses on the bottom. So it's you would move just the parentheses, and it's 2m.
Like this?
Yeah.
Exactly like that?
Yes.
Okay. Ah, sorry, my mistake.
It's okay.
2n to the minus 4th all over 2n to the minus 4th to what?
The power of 3.
So, a couple of ways to do this. The obvious way is to convert the bottom. What is the bottom equal to?
2 to the...
Oh, now that 2 is being cubed also.
Yeah, so 2 to the third.
Okay, which is 8.
And then n to the negative 12.
Okay, now simplify that.
So 1/4. And then on the top, n to the negative 4th. And then on the bottom, n to the negative 12.
And simplify that.
How do I...
Well, when you're dividing same base, different exponents, what do you do with the exponents?
I don't know.
You subtract.
Okay.
When you're multiplying, you add. When you're dividing, you subtract. When you are double exponentiating, you multiply. You always do one level less. You never do the same thing. If I have x squared times x to the third, you never, in other words, I'm multiplying x times x, which means I am never, ever multiplying 2 times 3. I'm adding them.
Okay.
That's x to the 5th. If I am dividing x to the 7th divided by x to the 5th, well, I'm always subtracting. That's x to the 2nd.
Okay, so it would be, do you have to...
Well, what's n to the minus 4th? Let's just handle that part. What's n to the minus 4th divided by n to the minus 12 if you have to subtract exponents?
8.
N to the 8.
Okay.
Okay, so this whole thing becomes n to the 8th, so you end up with 1/4 times n to the 8th in the numerator. So that's your answer.
Okay.
Okay. All right, how about C?
So it's open parentheses, 2n squared, close parentheses, to the power of -1, and then all over 2n squared.
Like that?
Yes.
Well, all right, let's do it the standard way, and then I'm going to show you a way that's a little bit better, maybe. So, if I had 2n squared to the -1 divided by 2n squared to the 1, which is what we have, what would you do with the exponents?
You would subtract them.
Okay, so what do you get?
0.
Nope. -1 is not 0.
Yeah. I was going bottom from top.
What's
So
-1 minus 1?
it's -2.
So that's what I get.
Uh-huh.
Now, the way I just did that treats that like it's x to the -1 divided by x to the 1. That's all I did. In other words, I assumed that 2n squared was something. You can call it x or q or a or b or whatever you want. But the fact is that I had something to the -1 divided by that same something to the 1. Well, that gives me that something to the -2. And that's how I got that.
Okay.
Now, I'm not quite done because I'm fairly sure that your teacher does not want your final answer to have any negative exponents.
Yeah.
So let's get rid of that negative exponent. First of all, simplify that.
So it's 2 to the -2, and then n to the -4.
Okay, now simplify that. Make all that positive exponents.
So then would it just be 1.
Whenever you see a negative exponent, you can always just make a fraction and put that on the other side of the fraction bar and make it a positive exponent. So there's my fraction.
And then it's 1 over, okay.
So that's what I'm going to do.
Uh-huh.
And that is 1 over 4n to the 4th. There's my answer.
All right.
That's all positive exponents. And
All right.
it's worth knowing this. What's that equal to?
X squared.
Yeah. In other words, if you want to move something that has an exponent to the other side of the fraction bar, just change its sign.
Okay.
So that becomes x squared. Okay?
Right.
If I have 1 over x cubed and I want to move the x to the numerator, then it becomes x to the minus 3. So it works both ways, whether you're moving a numerator to the denominator or whether you're moving a denominator to the numerator. If you do either one, you can just change the value of the exponent, or the sign, I should say, on the exponent.
All right.
And what about D?
Okay, this is a long one.
Okay.
8x squared.
8x squared?
Yes, and then y to the 4th, and then times 4x squared, y to the 4th, times 3x. And they have little multiplication signs. I don't know if that matters.
It doesn't. In other words, the way you gave it to me was like that, right?
Except the 3x at the end, yeah.
Like that?
Yeah.
Those parentheses don't mean anything other than multiplication. Well,
Okay.
if I leave them off, I've got the same thing. I don't need those parentheses any more than I need an X to indicate multiplication. I just don't need them.
Okay.
Okay, so the first thing to do is just get rid of all those unnecessary parentheses. Now, start with your number, go to your next variable, go to your next variable, go to your next variable.
Okay, and then
number. What's 8 times 4 times 3?
That's all over 3x to the negative 3rd and then y to the 2nd.
Now, these look like hard problems because there's lots of things there, but they're not. They're very easy problems. First of all, that 3 cancels with that 3.
Okay.
As long as they are not, you didn't omit any parentheses, right?
Yeah.
Okay. So now, what's the numerator? The number part of the numerator.
8.
8 times 4.
8 times 4.
Yeah, it's this times this. The only thing I canceled was that 3 with that 3.
Okay, yeah.
Okay. Now let's go to the x's.
Okay, so it's...
What's the numerator x's? We got x squared, we got x to the 4th, and we got x. So what's that all equal in the numerator?
No, it's 4x squared instead of 4x to the 4th.
Okay.
So it's 32x to the 4th.
Well, there's an x to the 1 over here.
Oh, yeah, 32x to the 5th.
Do not ignore that 1. That will make more mistakes than anything else. Just because it's not written doesn't mean it's not there.
Okay.
Okay. Now, we had an x to the... We'll do this in a couple steps. But so far, we got it right. Right?
Yes.
Let's combine those x's right now. What's x to the 5th divided by x to the minus 3rd?
8.
X to the 8 in the numerator.
Okay.
You have to make sure you get it in the right spot. Okay? Now we've taken care of that one and all the x's. Now let's look at the y's. What's our numerator y?
Y to the 8th.
And our denominator y?
Is y to the 2nd.
So what's that become? What's y to the 8th divided by y squared?
4. No, 6. Sorry.
And it's in the numerator because it's positive.
Okay.
If it was y to the minus 6th, then I would put it in the denominator.
Okay.
And that's as simplified as you can do. I've simplified all my numbers, I've simplified all my x variables, and I've simplified all my y variables.
Okay.
Okay? So these are actually very easy problems, and I could put 16 different variables. I could go A, B, C, D, E, F, G. You just take them one at a time. Take your number first, take your next variable, just do it until you're done.
Okay.
I'm not sure what we're looking at here again. I don't know why I'm missing the problems, but that's okay as long as you can verbalize them.
I was going to do number 6, actually, if that's okay.
That's fine. Is there some equation here?
Yeah.
Function? Okay. What's
So
the function?
So it's y equals, open parentheses, x minus 2, close parentheses, squared, minus 100.
Notice what format that is in. That is in standard vertex format.
Yeah.
Minus 100?
Yes.
In other words, standard vertex format is this. Y equals a times x minus h squared plus k. And h is the x coordinate of the vertex, k is the y coordinate of the vertex. And we know we're talking about a parabola because we're talking about a quadratic. We got an x squared term.
Yeah.
So they want to know the x-intercepts. Well, that's actually pretty easy. You just have to know one thing. X-intercepts mean y is equal to what?
I have no idea.
Think about it. If I have a function, those are the x-intercepts. What is y equal to at each intercept?
The distance across.
There's the y-axis, there's the x-axis. What's y equal to at that point?
I don't know.
Read it off the graph. 0.
Yeah.
What's y equal to right there?
0.
Okay. It's a hugely important concept, is that when you are looking for intercepts, the x-intercepts comes when y equals 0. The y-intercept comes when x equals 0. It's exact opposite, but it's hugely important. So if I'm trying to solve for the x-intercepts, what am I going to set y equal to?
0.
So now all I have to do is solve this equation. Go ahead. What's the next step?
Do the exponent.
No, not yet. You want to get rid of this 100.
Yeah, move me 100 over.
Well, there's actually a couple of ways to do this. You could expand this x minus 2 squared and then turn it into a quadratic equal to 0 and then factor it. But it turns out that's not really the easiest thing to do. The easiest thing to do is to move the 100 to the other side.
Okay.
And now we can take the square root of both sides.
Okay.
What's the square root of the left side?
X squared.
No. What's the square root of 100?
Oh, I thought we were talking. 1000.
No, square root of 100. What two numbers multiply together to give you 100?
Oh, 10 and 10.
Okay, how about 10 and minus 10? Notice that minus 10 times minus 10 also gives you 100.
Okay.
So never forget your plus and minus. That's critical.
Okay.
That's the second biggest mistake made in algebra, is people, when they are solving an equation where you have to take the square root of both sides, always begin your answer with the words plus or minus, always.
Okay.
Now, what's the right side equal to? We got to take square root of the right side.
So it's x squared and then minus 4.
If I take the square root of something being squared, the answer is that something.
So it's x.
X minus 2. In
But
other words, I was squaring the quantity x minus 2, correct?
Yeah.
So by taking the square root of that, I get x minus 2. And now I get x minus 2 equals to plus or minus 10, which...
But why wouldn't it be 4?
Why would it be 4? If you take the square root, if I have x squared and I take the square root of that, that's x, always. If I have the square root of x minus 1/7 squared, what is that?
X minus
1/7.
Yeah.
In other words, the square root eliminates the square. So this square root sign eliminates that. So I'm left with x minus 2.
Okay.
Okay? And if x minus 2 is equal to plus or minus 10, then x is equal to 12 when it's plus 10, and x is equal to minus 8 when it's minus 10. So those are your two solutions. And that's where your two intercepts are. And what is that going to look like? Well, this is a fairly standard quadratic. It's going to be a parabola. And it's going to go through those two x coordinates.
Okay.
In other words, it's going to go through minus 8, and it's going to go through plus 12.
Okay.
Parabola that opens up, something like that.
Okay.
Okay? But this is an extremely important rule, actually this one right here, is that when you take the square root of both sides of an equation to solve it, always begin your answer with the words plus or minus. I would say 95% of students forget the plus or minus. And if you forget the plus or minus, notice what happens. You don't get the right answer. You get 12 only. You lose the minus 8.
Yeah.
I've got 10 equals x minus 2, then x equals 12. Well, that only gives me one intercept. You know, with quadratics and parabolas, there's always two of them, if there's one.
Yeah.
So it's a hard thing to remember, but when you take the square root of both sides, always start your answer with the words plus or minus. I wish I had a song for that. I really do. I know they have a song for the quadratic formula. I have a song for the ABCs. I still wouldn't know my ABCs if I didn't have that song. But I don't have a song for if you take the square root of both sides of an equation, you have to begin your answer with the words plus or minus.
Yeah.
And just to be clear, if x squared is equal to 25, what is x equal to?
25. Or
how are you solving this? How are you going to go from this step to this step?
Square rooting.
Okay, so I'm going to take square root of that. I'm going to take square root of that. What words should your answer begin with?
Plus or minus
What's the square root of 25?
5.
That's your answer. It's not
Okay.
5. Most people would make the mistake x equals 5. That's not correct. It's x equal plus or minus 5.
Okay.
Okay?
So for B, it's y equals open parentheses x plus 4 close parentheses to the power of 2 minus 48.
Again, this is vertex format.
Yeah.
Vertex format meaning that h is -4, so your x coordinate is -4 on the vertex, your y coordinate is plus or -48.
Okay.
So we can tell where the vertex is immediately. But
yeah.
They're not looking for the vertex. They're looking for the x-intercepts.
Yeah.
So what we need to do is solve this for x, setting y equal to what? What is y equal to when you're looking for x-intercepts?
0.
It's next step.
And then it would be 48 equals x plus 4.
And next step.
Wouldn't it just be x plus 4?
Well, the next step is to take the square root of both sides. That's what the words I'm looking for.
Yeah. Yeah.
In other words, it's not just x plus 4. You have to take the square root of both sides. That's the only way you get x plus 4. So, what's the left side going to be? Don't worry about simplifying it, just for starters.
48.
What words does your answer need to begin with?
Plus or minus the square root of 48.
There you go. I mean, I don't want to be harsh, but I don't know how else to get people to know this. I cannot teach people this. I just can't. It doesn't matter how many times I say it. People don't deal with it. So now what?
Then you bring the 4 over.
Okay. So we got x equal plus or minus the square root of 48 minus 4, right?
Okay.
Now that needs to be simplified merely because that can be simplified. And they don't ever want you to give an answer that's not simplified.
Yeah.
So how do you simplify square root of 48? What is the square root of 48 equal to?
I have no idea.
Well, the secret on simplifying these radicals is to factor 48. So you're looking for factors of 48. In other words, that could be 4 times 12, but there's actually a better one, 16 times 3.
Okay.
And what I'm looking for is one of these factors to be a perfect square number.
Which is 16.
16, yeah. I could also have done 4. It just would have taken 2 steps. And I'll do that for you just to show. But this is clearly equal to 4 root 3, right? So now we have our answer plus or minus 4 root 3 minus 4 equals x.
So that's the final answer?
Yeah, it kind of is. You could say that there's 2 answers. The 2 answers are 4 root 3 minus 4. That's one of them. And the other is minus 4 root 3 minus 4. In other words, this plus or minus means 2 different things. In one instance, it means plus. In the other instance, it means minus.
Yeah.
That's the way to handle it. Now, this is a satisfactory answer to most mathematicians, but you may have a multiple choice question and they may say, what's one answer?
Yeah.
So you'd be looking for either that or that.
Okay.
Okay. Since we don't have much time left, we have 1 or 2 minutes, let me go over a few others. Just some simplification problems.
Okay.
Simplify that. Remember, you're wanting to factor it into two things, 2 factors of 50, and you want one of them to be a perfect square. So it's not 10 and 5.
So it's
10
2
is
and
not
5.
a perfect square. 5 is not a perfect square.
So it's 2 and 25.
Put the 25 first because that's going to become the whole number.
Okay, so it's 5 root 2.
Exactly. Now, let's go back to the other one that we just did. I'll just take 2 more minutes of your time.
Okay.
Square root of 48. Let's assume that I didn't realize 16 was a factor of that. And I do know that 4 is a factor. Okay. So that becomes that. You with me?
Yeah.
But square root of 12 can be simplified.
Yeah.
In other words, square root of 12 is square root of 4 times square root of 3.
Yeah.
So that becomes another 2. 2 times 2 is 4. So I get to the same answer, but it took me 3 steps to do it instead of 1.
Yeah.
So the secret on these simplifying radicals is to factor it where one of the factors is the biggest perfect square number you can think of.
Okay.
For instance, that is this. It's also this, but this is more efficient. That gets you in 1 step to 10 root 2.
Yeah.
This you have to do a bunch of times to get it down to 10 root 2. So you don't have to find the maximum perfect square factor. It just makes the problem quicker.
Okay.
You can always keep working it. In other words, if you factor it with a 4 instead of a 16, you'll find another 4 in there. Just keep going down until you can't factor what's inside the radical anymore.
Okay.
And that always works. That will always give you the correct answer. But if you can spot a factor that's bigger, that is a perfect square number, you're going to be better off. And it's worth knowing your perfect square numbers. In other words, these are your perfect square numbers because whenever you're simplifying, you need to find a perfect square number. So when you're factoring a radical, you are looking for factors where one of the factors is one of these numbers. That's the secret. That's what you always want to do. And it's most efficient if you get the biggest one. In other words, a 4 is a factor of 200. 25 is a factor of 200. But the biggest factor of 200 is 100. So this turns into square root of 100 times square root of 2, and that becomes a 10. So that's the easiest way to do the problem. So that's always the secret to simplifying radicals.
All right.
Okay. All right, Taylor, I will let you go. And you guys know how to schedule appointments, so I'll let you schedule whenever you, whatever suits your schedule next.
All right.
All right. Have a good week. Bye-bye.
You too. Bye.